So antimicrobial resistance can be caused by a variety of factors, and AMR arises because of adaptation of bacteria, resulting from mutations in their DNA, which can be caused by the stressful environments the bacteria are in. Sometimes these mutations can lead to a benefit for the bacteria, and one of which is antimicrobial resistance. Bacteria can exchange DNA quite easily, which means that they can also transfer resistant genes. So antimicrobial resistance can be spread among many different types of bacteria, which basically means that easily treatable infections are now becoming less treatable. So if we don't study AMR, then the infections that we could easily treat with antibiotics that we have now could become life-threatening with no available treatments. Bacteria are constantly evolving, and we need to stay one step ahead of bacteria developing resistance. So lots of things can be done, and investment for new classes of antibiotics, better coordination of animal and human surveillance systems, antimicrobial surveillance systems, and improvement of antibiotic choices are outlined in the UK's antimicrobial resistance strategies led by the UK Health Security Agency. But monitoring of data from antimicrobial surveillance systems can help anticipate future resistant rates. And the more data that we have and the more research that we do, the better informed our scientists and policymakers will be. So Dr Gemma Langridge has produced some inspiring work on using nanopore sequencing technologies to study large chromosomal rearrangements in Salmonella. And during my PhD, I will be using nanopore sequencing technologies to study the loci of AMR genes and to differentiate between chromosome and plasmids. I'm very grateful to have done a placement with Gemma, and the skills and knowledge I've gained will be invaluable to my career. So I never expected to become a microbiologist. I went through clearing to do biochemistry at University of Hertfordshire, and it wasn't until I did a 3-month summer work experience in microbiology where I started to fall in love with the topic. So I switched to do a biomedical science degree at University of Hertfordshire. And since then I've been in the field and I've done various research projects in AMR, which has then led me to do a biomedical research degree up in Imperial College London. And I'm now doing a PhD at University of Bristol with Professor Matthew Avison. And the PhD is part of a national PhD programme in AMR, which is multidisciplinary. And as part of the PhD, I recently finished my placement with Dr Gemma Langridge, where I learnt about long-read sequencing with Nanopore. So I have learnt about nanopore sequencing from DNA extraction all the way through to processing nanopore sequencing data. And this will not only help me set up long-read sequencing pipelines in the future, but also the bioinformatics associated with processing nanopore data will also help me further my own research in AMR and bacterial genomics. My main tip would be to be proactive and explore your interests. If you have any collaborators that match the techniques that you want to learn, it is definitely worth approaching them to ask about securing a placement with them. For me, I approached Gemma Langridge because she did nanopore sequencing on my Salmonella isolates during my master's project. So it's definitely important to be brave and don't be afraid to approach PIs when looking for placement opportunities.